Hello and welcome to the Engineering Futures podcast. I'm your host, Paul Barker, and I'll be helping you explore the world of manufacturing by introducing you to successful people from across the sector. We'll touch on everything from personal experiences and professional challenges to contemporary issues affecting the sector, careers advice, and practical steps for employers who are looking to attract the top engineering talent. Join us as we get to know the people who have made a difference within the sector.
Right, okay, so welcome to Mr. Paul Bullock from 3D360 for the latest episode of Engineering Futures. How are you today, Paul?
Thank you, Paul. I'm good, thank you. Yeah, really looking forward to having a chat today and just sort of talking about the Engineering Futures and what inspired me to become an engineer, and hopefully sort of imparting some knowledge on some of your to some of your listeners as well.
Yeah, so this is our second bash at this, isn't it? We had a failed attempt on Friday because of some technical issues, which I seem to be plagued with.
Yes, it's the scourge of the modern day, I think, isn't it? As we change over more and more to digital, more and more bandwidth gets consumed, services get more and more strained. So it's a blessing and a curse a little bit. It's great when it works, but it can be a little bit frustrating sometimes.
It can, but fingers crossed we'll be okay with this. So we'll get started. So well, firstly, Paul, if you just explain kind of who you are and kind of what you do.
Yeah, no problem. Thanks, Paul. So my name's Paul Bullock. I'm one of the co-directors of a company called 3D360. We're a trading provider and an engineering consultancy in fourth industrial revolution technologies in robotics, AI, 3D printing, AR, VR, and those modern, if you like, engineering technologies. Prior to that, I served an apprenticeship at Sellafield Limited, or British Nuclear Fuels, as it was then, perhaps showing my age a little bit. I served a recognised apprenticeship. That gave me a great foundation in engineering. The training at Sellafield was really second to none, and that really helped me develop and grow into a role in engineering. And then I spent the 30 years after that consulting in engineering for the likes of Sellafield and Magnox and some of the big blue chip engineering companies, predominantly doing nuclear decommissioning. And I studied sort of mechanical engineering, but there was a good mechatronics grounding in what we did. We studied mechanical, electrical, electronic engineering. And that led me, did that for about 30 years, worked on some really great projects for the NDA and Magnox and Sellafield. And in 2020, I took early retirement to go into education, and I started that a week before COVID, so that went a little bit west. But I'll talk about that in the next question and sort of how that brought us to where we are today. That in itself was the sort of springboard for 3D360 to be launched. And we launched that in 2020, so we're just about 3.5 years old now. And I've spent the last 3 years with my business partner and co-director having a public sector trading company and building up that client base. Really, it's something I'm keen to stipulate. I think sometimes that the company is relatively new. It's only 3.5 years old, but the heritage is old. We've been consulting at high levels in engineering across automotive and nuclear and aerospace for 30 odd years each. So we've tied all that together and really sort of brought that into an engineering company for the modern day, I'd like to say, embracing modern fourth industrial revolution technologies.
Excellent. So, yeah, I mean, I'm looking forward to this one today, Paul, because I think that, in terms of, I like meeting, I think people think that engineers are kind of stuffy, kind of sat in a room and like boffins, and they don't really do much outside of that. And it's great when you meet people who actually have deviated and have done kind of creative things and And so, yeah, I'm looking forward to this. But yeah,
you know, that's for sure. It has been an interesting journey. So we'll obviously touch on that through the podcast today. But hopefully that again will show people it's a great point that there isn't one defined route, there isn't one defined stereotype, there isn't one set of sort of core KSBs. Really, engineering is a huge topic. And it really requires you to have a multitude of skills and experience really to really become a great engineer. I think you've got to push yourself out of the comfort zone, and where we say might be mechanical engineers, it really takes you to have an understanding of electrical, of C&I, of civil engineering, and so on, to be a really well-rounded engineer. And that's hard. It's a lot of work.
Yeah, absolutely. Well, we'll kick off with kind of the first question, which is always the kind of first question I ask the guests. But who or what inspired you to become an engineer?
Brilliant, thank you. I love this question. It's a really easy answer on the face of it, because it sticks in my mind really, really firmly how my journey started in engineering. Although there's many different facets that led to it, there was really one pivotal moment. And that was science club at junior school. My old school, Holy Family, in what would have been in the 1970s then, which is kind of showing my age a little bit. But they started up a science club, an after school club. We'd call it enrichment nowadays, but it was science club in those days. And I had an interest in science. I like physics. I like mathematics. But I like tinkering with things. Like many people of our age group, you always had a push bike, and you had to keep that on the road, keep it maintained yourself and repaired and upgraded as well. So we were always sort of messing with things in those days. You're always repairing things. We didn't have this culture we have today where you were throwing things away. So I found that I really sort of enjoyed how things worked and taking them apart and repairing them. But really, science club, the enrichment side of it, just gave me that formal grounding, if you like, and showed me there was more to that. So, as simple as it sounds now, I can remember it vividly, making structures out of lolly sticks or straws to hold marbles, or how big a span we could make. Really sort of started answering those questions, or asking those questions, I guess. How does this work? How can I manipulate those mechanical properties? How can I make this perform better? And it all came from that one activity. I think it was a really defining moment in my career, and that just enabled me to really kick on. Then I did well at science club, but it was kind of fun. It was doing something we didn't do during the normal curriculums. It felt a little bit less like formal study and a bit more like R&D almost. Really exciting and different. And that really sort of focused me then on, as I was getting a bit older then, sort of looking at, this is something I can do. This is something I really enjoy. It's something I do at home, and that ties it all together. So that was the absolute pivotal moment. And it's one of the reasons I'm such an advocate of things like enrichment, after school clubs, and these extracurricular activities that really allow students a different perspective and a different opportunity. Students who might, not have these influences in their home life or day to day, it shows them another path, really. And I think the more of them there is, the better. So that's something I really took out of it. Now, my dad was an engineer as well. My dad was an electrical engineer for GEC. But that didn't shape me in the same way. I think I always sort of had at the back of my mind, I didn't know what an engineer was or what an engineer did, but I always saw that and thought that's a way to provide for your family, to get a house and all those things that come with it. So that was always at the back of my mind. But I didn't really tie the two and two together. My dad didn't come home and talk about work as he didn't in them days. It was very much the 9 to 5. He left all that at work.
Right.
So that didn't influence me other than being that father figure, that sort of respected figure, thinking, well, that's engineering, that must be a respected job or role, or what have you. So it did play a part, albeit a small part. I think that was more just a fundamental sort of reassurance, really, that works. That is a a potential pathway. But really, science club at Holy Family RC Primary School. So a big shout out to them if they're listening, and just a big thank you. That really gave me the grounding for a really good career in engineering. So eternally grateful to them. But it's something, like I say, that we really sort of try and drive home when we do work with educators and schools. I tell that story quite a lot because I think it's important, it's tangible. When they may feel that, is this really making a difference? Do they, it's hard to see what's going to happen in 5, 10, 15, 20 years in the future. But I'm living proof that type of after school club does work. And I'm sure there's many, many others. It'd be interesting to see through your series of podcasts, if any other people, if that's been that springboard for them. So yeah, that's in a nutshell. Sure. So mostly the science club, and then the sort of reassurance through my family, I guess, that engineering was a respected occupation. Although I didn't actually learn anything about engineering from my dad, which feels a bit odd.
Yeah, it's in terms of like those enrichment clubs. There's always the moment where that seed is planted.
Yes.
For everyone, I think for me it was doing design technology at high school. I don't know how old I would have been, maybe kind of like year 9 or something like that. But learning to draw isometric, doing like isometric graphics on a drawing board, and I just found I've always been creative, and I thought I didn't know what it was, and I didn't at that time think, this is like I might become an engineer. I liked the creative elements of kind of technical drawing and being able to get an idea out in a technical way and scaling and all that kind of stuff. I just found that quite interesting. But with your science club, was there a teacher in particular that kind of that delivered that you looked up to, or was it more just the club itself?
It was the club basically, and I've been racking my brains trying to think of that teacher's name, and I can't, which is a bit disappointing. So I will have to ask the school. But like I say, this is the 1970s. We're going back a bit. For me, it would have been about year 7. We did that year 7, year 8, and it's interesting. You mentioned about technical drawing and that being a springboard. It wasn't what inspired me to become an engineer, but I do talk about that in the next sort of question. That was the thing that when I started engineering that I really, really enjoyed. I was always sketching something as a kid. I really liked. I was quite creative. I always had a pen and pencil to hand, paper and pencil to hand, and I loved perspective. I loved sort of doing isometric drawings and drawings to perspective. And I found that when I started my life as a draft person, when I finished my apprenticeship, I really enjoyed that, and that really, I think, kicked me on. I sort of found my place there. I think when I went into the drawing office, it really all clicked a little bit, and I found a way to express that, to really do that diligence and sort of create those manufacturing drawings or engineering drawings of assemblies or layouts. I love that part of it. I think that was brilliant. And again, at an age before CAD. We take it for granted now that CAD's the sort of accepted technology, but a lot of people our age did start work on a drawing board. It did start with D&T and drawing pencils and the likes. And in some cases parchment. Some really old sort of mediums to draw on. I really enjoyed that part of it. I loved drafting and my AO drawing board, and I know when we switched over to CAD fully, if you like, at Sellafield, they got rid of all the drawing boards, and I kept mine. I asked if I could buy it, and I was able to take that home and use it as in the garage and what have you. And I love that, and I still do now today. I still love a bit of technical drawing.
Yeah, I'm the same. I'm going slightly off tangent here, but when I was working at college a few years ago, we needed someone to deliver pattern development with some of the weld and fab apprentices. And I said, right, I'll do it. But I had to learn how to do it myself because I didn't have a clue how to do pattern development. But oh my God, it was like, I loved it. Like going back to those kind of like first principles of drawing and thinking about it and getting that pattern development all done. Yeah, like square to rounds and stuff like that.
Absolutely.
How you would draw that.
Envisaging that in your mind's eye before you start.
Yeah.
It's easy now in a little bit with modern CAD. You can just get cracking. Back in our day when we started on the drawing board, you really needed to know where that drawing was ending before you started it, because if you got to a point where you were out of space, additional views, the scale wasn't right for the border, you were starting it again. It wasn't kind of like today where we just take that card, it's always 1-to-1, and there you go. You can't really go wrong in that respect. But you really have to plan that out, and you really have to sort of like I say, understand in your mind's eye how that was going to go together before you'd even put your first line in, really. So it took a lot of thinking about and a lot of logical thinking, all those sort of traits that really go together to perhaps make engineers, those things that people have, that diligence, the attention to detail. They all really come together in that sort of envisaging models in your mind and how that goes together and how angle projection works on that and where you need to be cutting your views and so you can see really what's going on in that drawing. There was a lot to it. It was quite a skill, and I love that. I love that. The neatness, the order, that you could create some really beautiful drawings in the day when it was by hand. But yeah, really, really interesting stuff. That I'll talk about that in the next section if I can. It grows.
Yes. So you've led, what I would consider to be, you've definitely a very interesting career, but you've done other things as well, which with the work in Cambodia that you did. But talk me through some of the defining moments that have led you to this point.
Blimey, yeah. So I'll try and keep on track. I'll try and keep it chronological. But there's just been so many. I have had quite a varied career. So since starting doing my apprenticeship at Sellafield, I'd say that was fairly straightforward. It was a mechatronics apprenticeship before that existed. So we did predominantly mechanical or electrical. We had to study the other disciplines, so it give you a really good grounding, so you understand electrical, you understand electronic engineering, even civils. One of my first jobs at Sellafield when I was in the rig halls was a civils job, and I was a mechanical engineer, so they wanted you to have that really good understanding of everything as a system, and I think that was massively important in showing me the crossovers between the different disciplines. And that served me really well as in later career as I was managing work packages, and as the mechanical we would manage the multidiscipline work packages. So I'd be responsible for the delivery and technical compliance of it all, and that then we'd have our individual subsets under that: the electrical teams, the civils teams, the vent teams, and so on. But it gave me a really good understanding of engineering as a whole. And I think that was really important, and is for a lot of engineers. I think where we touched on it at the beginning. I know Paul Bell touched on it last week, the vastness of engineering and how that can perhaps breed to imposter syndrome and thinking I don't quite understand all of this. And it's such a huge topic that I'm sure no one does understand all of it. It's good to understand sometimes that it is massive and that there's got to be that continued growth and development. So my apprenticeship at Sellafield was the key defining one, really. There's no two ways about that. That got me education, and it got me sort of vocational skills as well. It taught me how to be in work and do all those soft skills, or gain all those soft skills that we talk about are sometimes missing in the modern day. I think that hybrid of going to college and working at the same time and learning on the job skills, for me, it was the perfect mix. Not for everyone, I'm sure, but for me, I needed that blend of theory and practical to really keep me interested. I did like the theory, to be fair, but I was always kind of, in my early career, a lot of my engineering development and as a youngster was practical and hands-on. So that really just helps me to understand it, helps enable me to understand it, seeing that practical and marrying that up with the theory then. So that was hugely important. Coming through my early career, I think that was a massively important time as well. I had a really great time in my early career. I had some unbelievable mentors, which we'll touch on more in the next section. But the Sellafield had this sort of process, I'm sure many do, where as you came through your engineering apprenticeship, the years above you would be your mentors, as well as then some of the more senior staff. So you're always getting that constant sort of education, that constant update, that constant guidance. And that worked brilliantly. That had some people really stick in my mind. Ray Pashley, Tony Fifield, Dave Ashton and Ian Grady were my early careers mentors. And they were brilliant engineers in their own right, but they were really excellent mentors. And they really helped me find my place in engineering, helped me find my feet, really helped me develop and grow. I think that was hugely important, that it was a nice, safe and secure environment I could grow in. And that was we worked together collectively for many, many years, but probably about a decade and a half after that. And they were hugely important and influential. And I actually class that as a defining moment. Having those good mentors and guidance in my early career was what really enabled me to be the engineer I am today. So a big thank you to Ray, Tony and Dave and Ian and many others, if you're listening. So that was hugely influential. The next key point, I think this is, again, it's all interlinked. The next key point that I think really sort of boosted my career was care and maintenance on Sellafield. In the sort of late 90s, early noughties, Sellafield was under a care and maintenance regime, and historically the jobs we work on are quite large. You know, there's people I did my apprenticeship with who were still on the same job as when they were an apprentice and will retire on that job. And great, that means they can be really good experts in one thing or another. But the trade-off then is you don't get that broad brush, that sort of overarching view of how everything interlinks as a process system. And care and maintenance allowed me that. I worked on all plants, I worked on all jobs, I worked on different variety of things, whether that was installation, commissioning, whether it was mechanical, whether it was piping or vessels. I managed to get this really good grounding across the whole decommissioning ecosystem, and I rate that as a really formative several years actually, but a really formative time where I joined a lot of the dots, so I could understand a lot of what was going on, but it really helped me develop my process awareness as well. So touching on chemical engineering as well there, but it really helped me understand it. That was a brilliant time just because of how varied that was. And I think it's really important for a lot of the listeners or young engineers to do a variety of work, to see different types of jobs as well, because that all builds your knowledge as well. So the sort of guidance and advice there to the younger engineers is, if you get an opportunity, it doesn't matter whether it's linked to what you're doing, it doesn't matter whether it's not, whether you can see that link, just volunteer, be willing. That's the key takeaway. I was always willing to get stuck in and do work that was out of my comfort zone. And I think that all the way through my career has been really sort of defining, and that mindset is really what's helped me grow into the engineer I am today. So that was obviously really hugely defining. And then as I kind of developed and grew in that, I held sort of senior and lead positions through engineering then for a long time. And then what really changed, I think, there was, as I got further up the food chain and as I'd spent longer and longer there, I started realizing that for me, I was really enjoying sort of developing the early careers and bringing the graduates through, and even the older engineers, doing that continued development of them through my management roles, really got me thinking about being an educator. that's what really sort of set the seed. I found that I was really enjoying that development. Like I say, as when I was coming through, the engineers that had guided me and helped me and make me the engineer I am, I really sort of fell into that role, and I found that was where I wanted to be. So I put things in place, and like I said, I sort of took early release and went to be an educator a week before COVID. So that was hugely defining. I mean, that's totally changed what we're doing now. It's in fact the whole company was born out of that. So at the time, 3D360 didn't exist. I went to manage the Fab Lab at Warrington, where I'd been a STEM ambassador and worked with them for many moons. And that was where I felt I was going to sort of ease out the last sort of 10 years or so of my career. And COVID happened, and just everything changed, and that's hugely defining. So they obviously shut the Fab Lab and the school for quite a long time. And what we realised at the time, the 3D printed face masks and the vent valves were coming out, and we'd seen then little sort of snippets of the benefits we can get now from things like additive, supply chain resilience, reshoring. They really came into play as COVID kicked off. And what I did, I kept the Fab Lab open, so they were able to shut the school, but the Fab Lab was my domain, and I was able to keep that open because it was just me. So although I couldn't have the community in or clients, what I was able to do was get all the printers from the local schools and set up a manufacturing lab, or a print farm as it's called, multiple printers together to try and meet the sort of region's need, producing ventilator valves and the face masks. And what became clear straight away, so I got a lot of printers at that point from a lot of the local schools, and very, very few of them had been used. The first thing I had to do was sort of dust them off. That was a real shock. And then when I'd speak to the educators and sort of raise to come and pick up their printers and build the farm, the capability, it became really clear when I spoke to them that maybe they had a limited teaching resource. There might have been one person who knew how to use it, and they might have left, or during COVID things had happened. And in a lot of cases, they just weren't using those printers. So they had the hardware, but they didn't have the skills to know how to use them. And one school we work with, their head, I guess, of advanced manufacturing is a geography teacher, because he has a 3D printer and was the one in the school who knew how to use it. So that really struck a chord with me. And that was really the moment sort of 3D360 was born, really, as an entity. I realised that the educators needed a degree of educating. I realised that there was a big skills gap around fourth industrial revolution technologies. Again, 3D printing, robotics, all these other technologies. When I was speaking to the educators, they weren't there, and that forced me to look at the curriculums, Key Stage 3, Key Stage 4, and see where those gaps were and how we could plug those. And I realised that the key to making this happen was educating the educators in a sort of train the trainer type of style. So 3D360 was born, and that started off as a proposal to educate educators. That's exactly where it came from. And that's since grown, and we've grown that. It's not just educators now, it's companies, it's individuals that we have the funding for. And that's grown massively just into, providing that service across industry, across education. And it's been great. It's been absolutely really rewarding and humbling being able to sort of set up a system that brings not only the free hardware, the free 3D printers to schools that 3D360 donate, but then to also bring the free skills to schools that we get the budget for from Central Gov to incentivize that. And it's been a real privilege to be able to do that. We will just touch on the Earthship, the Cambodia one. I think is an interesting one. It kind of sums me up a little bit. This I'd taken a little career break and was motorbiking across Asia, and that was sort of, I do like travel. That is one of my hobbies. That was the main reason I I stayed as a contractor for so long was because I had that ability then to take more extended periods between contracts and get some traveling, some diving or scuba diving or motorcycling. And I'd spent some time motorcycling around the temples of Angkor. So in Cambodia, people are probably familiar with Angkor Wat, the quite iconic, huge temple there. But that's just one of 72 temples spread over a huge area in Cambodia. And I'd set up a trip where I was buying a motorbike and then riding around these temples and looking at them. And these are vast, bear in mind. The Angkor Wat, I think, is 5 kilometres around the perimeter. It's a huge building made of about 1,100 years ago, handcrafted by people. And I found that fascinating. It's the same when you go to the pyramids. These things they're just fascinating that we were able to make them before we had all the technologies we have today, before we had all the tools. You know, I can guarantee you they didn't have the theodolite around that we, as we know it, but they had these methods and methodologies of creating these buildings that literally last millennia. So is there some learning we can do? But I find that fascinating, that history. And while I was there, I'd sort of been learning the language because I was going to some remote places and I needed to understand that. And in one of the remote places, I met up with a lady who had a proposal to build an Earth ship, which for your listeners, if anyone's not familiar with that, it's a passively designed carbon neutral dwelling built from upcycled or repurposed materials. So that's a bit of a mouthful, but essentially it's a sustainable building. So I helped design that, and I was the chief engineer on it. And we built that Earth ship. It took us about 5 months. But it's a real thing of engineering beauty and a real thing of physics beauty. Essentially, it just follows all the principles, or the first principles of physics that we used to use. We've used them for millennia, and then when the Industrial Revolution really took hold, we kind of forgot a lot of these principles like solar chimneys and convection and thermal mass that we've been using for so long. And even the key to that, so that airship, it really is beautiful. I'll send a picture through to you just so you can visualize it. But the key to it is it uses no power, and that's it. It's absolutely self-sustainable in its own right. And the key to that is just designing it in the right orientation. So we put houses in nice, square, uniform, parallel and symmetrical roads. It's very much, the UK roads are very much like that, and cities and development. But really just being able to orientate that building in the right orientation with the sun path is the key to actually not needing to then use power to heat it or not needing to use power to cool it. So it was a really, really beautiful thing. And it's now become a bit of a showcase. So it's that building, although it's built from tires and dirt and basically bottles that they don't recycle, glass bottles or tires, car tires in Cambodia. So we used them. They were the waste that we had available. We packed about 1/4 of a ton of earth into each tire, and that created a really big thermal mass. Behind that, we built that into about 230 tons of earth, so that and orientated it with the sun and with the sun path. Certainly the winter sun path. So that then comes through the bottles, which is the walls, changes the light wavelength and heats the thermal mass behind it. And then obviously we put in composting toilets, did a well, made a farm around it, and it's actually become a sustainable education centre now as well, which I'm really proud of. And I still keep in touch with the school. Well, it's called a free education centre. I still keep in touch with them, and at the moment we're just devising our plan for me to teach them 3D printing, and certainly to teach them how to upcycle waste materials into a material that they can then use to 3D print with. And when I get a minute, we're going to go and 3D print another sustainable education centre there to sort of support the Earthship. But that's quite varied, but again, really good knowledge and understanding, really, to understand these first principles of HVAC and these first principles of physics and engineering are just hugely important. Again, it just pulls together more pieces of that jigsaw, of that engineering jigsaw. So anything that's a little bit different is obviously always a good opportunity to learn. But yeah, I thoroughly enjoyed that, and I'm really looking forward to carrying on that education. But yeah, quite varied, I must admit. I've been a kind of lead engineer for a lot of years, probably for about 25 years, and although that didn't really define my engineering career, it did change it, and I think that's important. We'll touch on that in the next question, but how that transitioned. And again, I know Paul Bell spoke about it last week and gave a good story about when it, having dinner with the team and not having dinner with the team, and that was really defining on the big scale of things. But it doesn't break down to one single moment or another, so it just changed things. That I think that one.
Yeah, so I mean, really interesting. A few interesting things that you've said there. When you talk about, if you take it back to when you first started, about being able to, those 3D printers that come back from schools that are kind of dusty and have never been used, and I think that's not a reflection on the school. I think that's just sometimes they don't have that skill set to be able to do it. But I think that when you engage with secondary schools, and these are people that are working very, very hard under difficult circumstances to get these kids through their main qualification. But when you think of these things that are happening because you might have had that teacher at school that did it, it's not the case out there in schools, is it? You've got sometimes, as an engineer, because I actually looked at this, I once looked at trying to go into secondary school, into secondary education. I couldn't get in. So I was thinking that they'd be like, oh my God, can you start tomorrow? Because I had a teaching qualification. I was an engineer. I was a time served engineer. I taught on programs within further education, but I couldn't get in because I didn't have like a little part of the PGC that you need. I think you QTLS or whatever it is. So how you get people with those skill sets into secondary education is more or less impossible unless you've gone straight down that PGCE route that gets you in. But I mean, how do you think that, because how do we nurture a pipeline of engineers, especially when you're talking about additive, that's going to be so kind of, and we can talk about that a little bit later on in terms of how the technology is advancing and stuff, but we need young people to be coming through. Like young people are savvy on smartphones and things like that. Well, they need to be savvy on things like additive manufacturing. So how do we overcome that?
They do, and it's a really good point you make there. You almost think, well, that's a really transferable skill I have with the teaching qualifications as well, that should be quite an easy transition, and it's kind of clearly wasn't, or at the time. And I think that's important. We do need that industry experience as well, and that employer experience. And I think it's really difficult for the teachers. There's no disrespect to them, like you said. It's probably it's a really difficult job. And I think what it is, what people probably don't see is that lag of the curriculums behind where they are. So if someone's a newly qualified teacher today, even the lag in the curriculums mean that additive isn't in there, that robotics isn't in there, and those more modern technologies, and they'll take a few years. That might be 5, 6, 7 years before that's in the curriculum. Then the teacher has to study that, become qualified, do the PGCE. Realistically, that's probably a 10-year lag. And some of the curriculums were behind. I know we've been reviewing some of the ones for Pearson's, and there is that lag. You can see it. And I think it is difficult for schools. It is difficult for teachers. And I think this is where sometimes with teachers, I think that's where we can really plug those gaps and get those little wins doing CPD in a specific skill that they can then bring back to the school. And we do it successfully in industry. These rapid upskill industry and employers tell us that's what they want. We do a lot of engagement. We did a lot of engagement with the high value manufacturing catapult in developing a lot of our curriculums. And that's the key takeaway, I guess, really is employers are really receptive to upskill training and CPD, but it needs to be quick. It needs to be something where they can be in and out. Schools, especially getting time off, is really difficult for teachers, and expensive. They need to be replaced as well. So it's a bit limited, but it's being specific about picking them upskill activities then, and getting the best out of them. And to be fair, I think we've trained they'll be getting on for about 300 educators under our funded programs. And they've just all been really receptive to this, that opportunity to do CPD, the opportunity to sort of plug a couple of gaps whilst the curriculums catch up has been really well received. And then we've been doing backfilling, if you like, updating the curriculum. So that's something we've been doing at level 4 and level 5 to try and tie this together. And what we've found when we talk about enrichment at the beginning, what we found is where schools now have this equipment and the teachers have the skills, they're bringing those topics into the key stage 3 and key stage 4 curriculums, because they're written that they can, and it gives them flexibility based on, if you like, what level of equipment they might have, whether that's resistive materials, a couple of hacksaws and a file, or whether it's digital manufacturing equipment. There's quite a bit of flexibility in there for the schools, which is obviously good. It levels it up a little bit. But we found they've been really receptive to that opportunity to upskill, and most of the schools we've trained have brought in some sort of 3D printer club, enrichment club, after school activity. And it's really encouraging that. And then when I look at it today, and I think this will be what some of our next generation and workforce of tomorrow will be doing additive or going into engineering, because they've had access to this equipment and these skills. So I'm really proud of that, but it's hugely important as well. So rapid upskill, I think that's the key for teachers and for schools, and that's where we need to kind of get education and employers talking a bit more. I know I've made a few notes on that further down, and the collaboration and connections really between employers and industry that historically haven't been that strong. But I'm seeing really encouraging work around it now, where there is a driver to tie those two together, and there is a driver for those different stakeholders to work together and really output the best curriculums for the next generation and the workforce of tomorrow.
Yeah, and then I suppose this kind of then leads on to, if we talk about additive manufacturing.
Yeah.
How do you see the technology? Because I've been over to I'm thinking, like, most people think 3D printing, and you imagine like a little 3D printer, producing a cube or whatever. But, the technology is so kind of advanced now that it's almost kind of mind-blowing when you see it. But how do you see it evolving? But then as well, what are the obstacles to actually getting this rolled out? Because where you've got kind of like SMEs, that's often not the case,
No,
and how do you see this technology being kind of rolled out amongst these companies and having the confidence to embrace it?
Yeah, it's a really good question. I think the sort of the first answer to that is it's so vast and varied. When we talk about additive, it's similar to engineering. It's a huge topic, and our preconceptions of additive or 3D printing are very much like you say, the desktop plastic polymer printing cubes. That's kind of what you see in your mind's eye when someone mentions 3D printing. But it's such a vast topic, and there's 7 different main types of additive, and then there's subsets within that. But what people generally don't see is the same technology can produce multiple things. So when we train in it, we keep metrics on people's job roles, what they come to us from, and how they're going to apply it. And it surprises us even sometimes, the diversity of that. We have therapists who use it as a rehabilitation tool. We have people who use it, yes, as a manufacturing tool, as you would expect. But we have people who use them as educational aids, good rewards aids. We have people who use them as a hybrid to support maybe art, sculpture. It's vast. And I think it's, there's a few things with additive, I think, that we need to sort of understand to be able to understand it. And one is, it's hugely different from anything we've known. It changes the paradigm, it changes the way we have to design, it changes the way we manufacture and assemble, not least because we can manufacture moving parts. All of a sudden we can manufacture the unmanufacturable, and that's a real game changer. So where we were constrained, if you like, by manufacture and assembly, we're not anymore. We can make anything. And that's difficult to get your head around in the first place. The fact that it can make moving parts, I always carry a lot of props, which I've got some here, but moving parts and multi-part assemblies, again, sort of changes the way you need to think about additive. You know, we're trained in traditional engineering, design for manufacture and assembly. But what happens if you don't need to assemble? What happens if you can just make everything in one piece? How does that change it? And that's what you can do with additive, and we do successfully, you know. And here's one example, but it's a great one. This chainmail. Chainmail's quite labour intensive to produce. We just make it as one piece now on using additive, but and we can do this with a multitude of things, even internal sections, ratchets. Internal galleries. We can make things that were never possible to make before, and that's opening up new avenues around cooling, heat exchange, all sorts, and even reliability. Not having that tolerance build up from being able to create multi-part assemblies in one piece just means we're getting more reliability and less fatigue. So it does change that mindset. I think one of the big challenge at the moment, which is being addressed, I guess, although I've never quite understood this, the big challenge is always about certification, standardization, compliance. How do we know repeatedly that part that comes off is going to be the same each time? And I find that a bit of I don't think it's that valid a challenge. As someone who's been underpinning things from first principles most of his career, I don't see it being any different. If we did have bespoke one-offs, we'd just test them, and we can get a feel for that material. So I think the challenges around standardization have come in. I've seen ASTM issuing new specs around it. Even there was a new spec around concrete 3D printing, which ties in, if you like, concrete 3D printing and testing performance for traditional civils development. And that's really exciting. I think that's a brilliant sort of piece of literature. And that, again, just ties that up in 3D printing. I think a lot of people preconceive this desktop thing, but just down the road from us in Accrington, they've given planning permission to 3D print a whole village, 46 houses, using extruded concrete. And I did have a chat with them the other day. It's really interesting how they've underpinned that, and they've got that to code. That is to the UK building regs. So where we look at these things and see the challenge, I don't think it is. I genuinely think the likes of in-process monitoring and performance monitoring and mechanical testing and standardization just allows us to get there quicker. But it does need more work on that side of it. I think that's just been a little bit slower coming to the party. But the reasons we should do this, why should we sort of change what we know? Why should we go away from something that we know it might bring risk? We know what we know. There's no risk in that. So why would we change? And I think the sort of outputs of additive are what's really driving that change. Some of the advances in materials. There's a material on the KERS system on the Formula One. It's a Stratasys material. They 3D print it. It's a liquid polymer resin. Can make absolutely incredible accuracy parts with that. We can make incredible detail and unmanufacturable parts. But that material is about 10,200 megapascals of tensile strength, 22 times stronger than steel, it weighs nothing, it's a polymer and it can be manufactured in any way. And these sort of increases in mechanical properties are good reasons we should look at this. The materials savings, I think, is hugely important. I think it's easy to overlook. We call additive manufacturing, because of the way the process works, it adds material instead of taking it away. And we never really used to call traditional manufacturing subtractive. But that is huge, and just saving that material. I'll bring out another example. Saving that material. This is a ratchet spanner off the International Space Station, designed by NASA. But you can see this internal material isn't solid. It's just a series of meshes. It's like a biomimicry. Now that actually uses about 10-15% of the material as if it's solid. And then I'm also not machining material away. There's zero waste with that. So I'm literally just material where I need it. On average, that's usually 5-10% of the actual material use. And this is biomimicry. So we use this lattice structure to really distribute the loads and for the load path. And that's how your bones work. Your bones are 3 to 5% density, but incredibly strong. And we use that in additive. So say for this spanner, this is 3D printed. The original was 3D printed on the International Space Station. It enabled NASA to email that file instead of using traditional logistics. So the carbon savings there were huge. Then we're not subtractively machining the material, taking material away. Again, huge. Then we're lightweighting and using much less material internally. Again, it's huge. We need less duty, less work, less energy for that. If it's a mechanical component, maybe off an airplane or a car. And then steel production is massively energy intensive. I think if steel production was a country in CO2 emissions, it'd be the 3rd highest CO2 emitter on the planet. So if we can use 5-10% of the material for everything we do, save all those logistics and all the carbon uptake from that, then yes, we've got to look at it. 3D printing a house takes about 4 days, uses a lot less material, there's less welfare requirements, there's only about 4 people needed to make that structure, that superstructure. So it's the drivers for additive. If we, that's what's really driving this. The advancing materials, I think, is incredible. Those ceramic polymers and some of the materials we're seeing today that do perform the same as metal, or can perform better than traditional metals and steels, is really changing things. And that's hugely important. So the incentive is there, basically. Underpinning why we do it is there. And I think we just need a concerted effort around standardising it all, and the underpinning of it, and we'll be okay, we'll be there. So, but it is going to change the way we manufacture, and that's a given. And in reality, I think it ends up being a hybrid method, where we can create near net shapes using metal additive, and then just face them, say where we need geometrical tolerance in, and really fine sort of finishes, and getting the best of both worlds. Then we're getting that lightweighting, we're using less material, and we're wasting much less if it comes to sort of fine machining. So I see it being a hybrid process, but additive will change the way we manufacture, and it will change engineering. And that's something I've been acutely aware of. There's sort of about 15 years I've been in additive. And what first struck me when I started doing it was, this is a game changer. I can't believe what this can do. And that's what we find when people start using additive. It's easy to sort of say it, you can manufacture anything, but you can. And that's an absolute game changer. And engineers can see that as a tool and really exploit it, as engineers do.
So I suppose with that then, because, and again, this is another thing with engineers, people think that sometimes technology can scare people, can't it? And I think with this, so when you talked about that lag in education, and is there potentially a lag from rolling this out? Because this isn't new technology, is it? I know people talk about it as though it is, but it's been around for quite a while.
Yeah, absolutely.
And what do you see the kind of like the barriers being for wider rollout?
Absolutely. It's the skills, it's understanding it as a process. Like you say, it's not new. You know, it works on a language from the 1940s, G code, which is the language of CNC, CNC machines. That's not new. I remember when I studied, when I was at Warrington Tech, they had a 3D printer there, and that was in the sort of 80s. And I remember that and looking at it, and at the same time, I was putting ticker tape into my machine, into my CNC machine. But it's not new at all. I think what's really new is the advancement in materials and the breadth of what we can print, concrete printing and the like. So it's materials that's really changed it. But I think what's if you like, stopping it becoming a mainstream technology today is skills. That's the key takeaway. And I know a lot of my engineering teams don't and wouldn't historically have the capability to be able to design for additive. It is a different process. Whereas people are used to designing for, you know, milling, turning, all those traditional processes, they're not used to designing for additive. And that's the key barrier really, is that lack of understanding on how we can use it, what, you know, the best properties we can take from that and where it can really benefit us. People don't understand, engineers, because they're not trained in that. And that's the gap really. If I was to do a gap analysis today, it's around skills. And we've obviously been on this mission to try and bring these skills into education, try and bring these skills to employers and into engineering. And that's the key. That's what's missing, if you like. If you can use this tool and you understand it, all of a sudden you can create anything. So it really is training. I think that's the only thing. And when people understand what you can do with it, then they can start bringing it into the businesses. And we've seen a massive progression in Manchester and the Northwest from that, really, since we've been doing our funded training, that's enabled people to explore these technologies at no risk. It's been able them to sort of get funded and subsidised training to upskill their staff and do CPD. Then they're bringing it back in-house and really exploring the best of it and what it can bring. And people who are using it and exploring it are really doing some amazing things. And that's the key, really. It's just getting started. And that's why we come in. We can, you know, provide you with a free printer and provide you with the funded training, just to enable you to start looking at, can I bring this into my capabilities? What can it do? And there's still an education piece there. I think, you know, until this is mainstream in schools and colleges and FE and HE and FE, and subsequently employers, then I think we're always going to be sort of, we're always going to be having this battle, really, of here's what it can do. Do we have the right people who understand it? So it's a sea change from what we know, basically. You know, this is a whole new way of engineering. And I think it's easy to underestimate that. If you don't know additive and you're not familiar with it, I think it's easy to underestimate just the impact this is going to have and just how powerful it is as a manufacturing technology.
So if anyone's been listening to this today, Paul, and they want to hear more about additive manufacturing, about training support, or just have questions to ask, what's the best thing for them to do to get in touch with you?
Yeah, so thank you for that. I mean, we're always happy to speak to people if they're not sure whether they can implement it into the business, or whether it's even going to work for them. You know, we use a phrase, just because you can 3D print something doesn't mean you should. Sometimes it's not the best manufacturing technology. And we're here to guide people on that and help them implement Industry 4.0 technologies into their business. So they can contact us, obviously. They can give us a call and just ask to speak to us. You can email in. And I'm sure, will we post the addresses, I guess, and the phone number in the link to this? So yeah, I won't talk through them, but we're more than happy to have a discussion. And certainly for businesses, we do go to a lot of employers and do training audits and technology audits where we can look at those manufacturing processes and sort of say, can this be improved by additive? What skills do you need then to be able to optimize your use of this technology or get the best from this technology? So we support employers in that. and we're able to provide funded training or subsidised training. We still maintain our free 3D printers for all. So I think we've given away about 1,250 free 3D printers to schools and businesses in the northwest of England. That's a great way to just see if this can work for your business at, again, low risk, low cost. But we also do a service, a free service, where we're happy to come in and look at your processes. We're happy to have a discussion, and we're happy to do a skills audit and see what employers need to implement this technology, and even just see if it's the right technology for the business or not in the first place. But we're here to hold employers' hands, and I think what works really well on that is we're not just here at the front end, we're here at the back end. Anyone who's been on our training courses, we offer ongoing free help desk on that, free technical support, and that's hugely valuable for companies. It means you might be cracking on, doing great, and then 6 months down the line you reach a roadblock, you're not sure what the answer is. We're here, and that's a free service we offer, because we want our learners to have the best possible chance of success. So we're there for ongoing support, and I think that really ties it all together as well. But yeah, contact any member of the team and just have a chat with us, and we'll happily have a look at if it works for the business and what skills might be needed and what equipment might be needed for that.
Okay, well, yeah, sounds like an absolute no-brainer to me. But Paul, we've come to the end of our time now. I had a few more questions I would have liked to have asked, but it's been so riveting, and I think we've been able to go into some really good detail there. So thank you very much for your time.
You're welcome. We can always set it up for a part 2. I think I've just set it up for the sequel. Like any good franchise. But no, I mean, there's a lot more I could talk about as well. I think it's a really good high level on that one, and it keeps in the theme of what you're doing. But I'm more than happy to do deeper dives on this as well, and talk about the environmental benefits and the business benefits and capability and cost benefits of these sorts of technologies. So, like I say, I'm always happy to have a discussion if anyone wants to pick up the phone.
Top man. Right. Well, Paul Bullock,
thank you for having me.
Thank you for your time.
It's been an absolute pleasure, and I'll look forward to catching you up at the next one.
Good man. Cheers, Paul.
Take care. Thanks, Paul. Bye-bye.